Okay, so welcome everyone to our Boise State University Anthropology Department seminar series. Today, we're really fortunate to have Robert Kelly speaking to us today. Bob is one of my mentors and close colleagues. I don't think Bob needs much of an introduction whatsoever. We all know Bob's work. We're really excited for our students here at Boise State to have this opportunity to hear the person that writes not only their introduction to archaeology textbook, but also the book that we use in our hunter-gatherers course. So a person that authors two prominent textbooks in our courses is here to speak. So just a little bit about Bob. Bob's been doing archaeology since he was 17 years old. He was a wily teenager that met a man named David Hurst Thomas in New York. Bob grew up in Connecticut. Bob started doing Great Basin archaeology when he was in his teens. He went on to do undergraduate degrees at Cornell, master's degrees at University of New Mexico, and his PhD at the University of Michigan. He worked at the University of Louisville before moving to the University of Wyoming, where he's been since 1997. And recently, Bob has been, for the last 6 years, been collecting a large radiocarbon data set with NSF funding that we can use to reconstruct deep histories of human population growth at the continental scale. So without further ado, Robert L. Kelly.
Well, thanks, Eric. I'm assuming that you can see my PowerPoint screen there?
Not yet.
Not yet. Oh, that's interesting.
There you go.
There it is. Oh, there it is. Okay. Okay, well, good. Well, thanks for having me here today. And I told Eric that I would talk about this particular problem of North American archaeology, which is, I'll let you in on a secret. This is one of the most contentious topics of not just Western Hemisphere archaeology, but really of global archaeology. It inspires remarkable debates, sometimes a little ugly, and it's something that people usually have pretty strong opinions on. And I've got my own, and those biases will undoubtedly come through in this talk. So the first thing you should know is that if you had asked somebody else to give this talk, you might end up with a very different answer than the one I'm going to give you. And a good chunk of my answer to the question, what might we know, is, well, we don't know much of anything at the moment. So the other part of this debate, the central question is, when did people arrive in the New World, the Western Hemisphere? And this, like I said, is a hot button topic. It appears to be of great interest to the public. The papers about this always get lots of airtime in the popular science literature. And it's also a subject that is of keen interest and often upsetting to the indigenous populations of North America. And I don't fully understand this, but I think there's a sense that if we conclude that people were here not a terribly long time, that somehow this lessens indigenous people's claims to and rights to land. So let me just say, if the ancestors of the indigenous peoples of the Western Hemisphere arrived in this hemisphere 1,000 years ago, 10,000 years ago, 100,000 years ago. In my opinion, it certainly doesn't matter in terms of their land rights. They were here first, and they've gotten certain rights that can't be ignored. So, a lot of what we're going to talk about today is concerning when. When did people arrive here? So let's go through a little bit of history here. This question of where did the indigenous peoples of North America come from and when did they get here has really been a central question that Europeans have been asking really ever since they arrived on the continent some 500 years ago. And they asked this question really for the reason I just gave you, which was if they've been here a really long time, then they've got some really secure rights to the land. But if they haven't been here very long, then maybe those rights are not so secure. So it became a kind of important, a politically important question. And although the question was asked for quite a long time, we didn't really get close to the answer until the late 1920s, during the excavation of a site known as Folsom, a site which has also given its name to these distinctive spear points that are found at the site. And you can't talk about Folsom without mentioning that the site was found after apparently a horrendous flood, but it was found by this man, George McJunkin, around 1908. And Mr. McJunkin was a former slave from Texas who acquired his freedom in 1863, and after the Civil War left Texas and went to work as a cowboy in New Mexico. He eventually became the foreman at the Crowfoot Ranch, where this site was found. And he was the one who found it and brought it to the attention of some other folks who, unfortunately, after McJunkin passed away, the site came to the attention of the Denver Museum of Natural History and was excavated. They found spear points like this in association with the ribs of an extinct form of bison, Bison antiquus. It was about half again as big as bison are today, as modern bison are today. They couldn't date these really well back in the 1920s, but they estimated that the site was at least 10,000 years old, and so that the ancestors of indigenous peoples had been here for at least 10,000 years. And it turns out, based on some work that was done at the site later on, they weren't far off. They were pretty dang close to the right answer. Soon after a Folsom site is found, there's other artifacts found at Blackwater Draw by 1932. They found those same Folsom points at the site, and down below them they found a larger spear point, still with this distinctive flake or flute removed from the base that acquired the name Clovis from the nearby town of Clovis, New Mexico. So they knew that there was something underneath Clovis. Yeah, they knew that there was something underneath Clovis, underneath Folsom, sorry. Turned out to be Clovis, and later archaeology would then show that Clovis points were at least, let's say, in the neighborhood of 13,000 years old. we're going to come back to that question of how old Clovis points are in a moment. So ever since that discovery, 1930, in the 1930s, North American archaeologists have continued to ask the question, what came before Clovis? Was there something pre-Clovis? And lots of candidates have been suggested, and not all of them have withstood the test of time. By the 1960s, there were archaeologists excavating at a site in Southern California, the Calico site, which when I was an undergraduate, this was a site that was being intensely debated because it was alleged to be about 300,000 years old. And the stone tools that were found there appeared to be very, very crude stone tools. But at the same time, archaeologists were saying there are really three criteria that a site has to meet in order for it to be considered evidence of a pre-Clovis occupation of the Western Hemisphere. And those three tests were that you have to have indisputable artifacts, which a Clovis point, that's clearly an indisputable artifact. But these from Calico, they just look like broken rocks. They have to be indisputable artifacts. They have to have indisputable dates associated, and the association between the artifacts and the dates has to be indisputable. And a lot of sites fall down on one or more of those key tests. Calico falls down on the first test. These are not artifacts. We now know them to be geofacts. They're just rocks that Mother Nature has broken in ways that kind of look like tools to some people. It's simply a fact of the matter that if you dig a big enough hole, which they did at Calico, and look at enough rocks, which they looked at literally tens of millions of rocks at Calico, you're going to find a few that could pass as humanly manufactured, when in fact they've been made by Mother Nature, in this case, rolling rocks down a hillside in mud flows a long time ago. Nobody considers this site to be a contender. But there have been others that were raised over the years, many of which were poorly reported. They didn't seem to be very good candidates until we come to this site, Monte Verde in southern Chile in the 1970s. There are indisputable artifacts at this site. There's a lot of curious things about this particular site that I'm still worried about. And the dating of the site appears to be 14,500 years old. That is, it's more than 1,000 years older than the oldest dates we had on Clovis in North America. So the question is, why is the earliest site in the Western Hemisphere at almost the very southern tip of the continents? And this has been followed by a couple of other sites, Huaca Prieta, which is still being excavated in Peru, which appears to date to close to 15,000 years ago, and the site of Arroyo Seco in Argentina, which seems to be about 14,000 years ago. This is a bit perplexing to have the earliest sites, the greatest distance from the Bering Strait, which you probably all know from grammar school, is where we fully suspect the ancestral population of the indigenous populations of the Western Hemisphere came from. We'll have more to say about those sites in a moment. There have been some others that have been proposed. One is the Topper site in South Carolina. which apparently is 50,000 years old, but like Calico, the artifacts here are not terribly impressive, and I've handled these artifacts, and I am not at all convinced that they are anything other than broken rocks. And the archaeologist in this case, he's a very good archaeologist, Al Goodyear, hasn't, in my opinion, demonstrated that these are actually humanly manufactured tools. You see an example of one of them there. More recently, just a few years ago, there was an article published in Nature, which is the Cerruti Mastodon site in California, which has been dated to about 130,000 years ago. The dating of the site is probably accurate. The question here is whether we're actually looking at an assemblage of stones and bones that were produced by people, or whether they weren't produced by something else. In this case, we've got a bunch of mastodon bones that have been broken, and they are found in association with some large stones, some of which are argued to be the anvils, and the others are the hammers that were used to break open these mammoth bones to get at the marrow from the bone, or to perhaps manufacture tools from the bone itself. It also includes a tusk. You're looking at the sort of top end of the tusk, because this tusk is apparently embedded vertically in about 75 centimeters of sediment. And the argument is that it couldn't get that way except through human action, human agency. This site was actually excavated in the early 1990s, and it was excavated not by archaeologists, but by paleontologists who, frankly, they dig sites a little differently than archaeologists do, and they think about them in a different way. I don't think this site is what was produced by people. I think it's a natural accumulation of bone and rock that has eroded down into a sandy deposit from a higher stratum that was a high energy stream deposit. That high energy stream deposit was later eroded down into a sandy deposit. In my opinion, that's the only way this tusk could end up in a vertical position and buried in 75 centimeters of sand. Nobody could jam a tusk down into sand, and there's no evidence that somebody had excavated a pit and then put this tusk, for whatever reason, vertically into that pit. I don't, to be blunt, I don't believe it at all. And just recently, a year or so ago, there was another site just published, again in Nature magazine, from a site known as Chiquita Cave in northern Mexico. At this site, which they excavated quite a large amount of sediment from this site. The excavation covers 62 square meters, and in places it's over 3 meters deep. The strata in this site are full of what's known in French as éboulis, which is just a lot of broken rock that's breakdown from the ceiling, but it's also flows of rock that are coming in through the mouth of the cave and washing into the cave itself. In other words, they excavated millions and millions of broken rocks. And just as with Calico, if you look at millions of broken rocks, you'll find a few that look like their artifacts. This is another case where I'm not at all convinced that it is what it claims to be. And what they claim it to be is evidence of humans in this part of the Western Hemisphere at 33,000 years ago. And they claim that this site was used from about 33,000 years ago up until about 10,000 years ago. And then for some reason, it stopped being used. You're seeing an example here of some of the alleged artifacts. None of them are things that are as indisputable as a Clovis point. That doesn't necessarily mean they're not artifacts, but the excavators would have to prove that these are something other than the rare stones broken by Mother Nature that end up looking like stone tools. I think they're all broken rocks. And a piece of evidence that backs this up is that there's no human DNA in this cave. Today, we have the ability to take sediment samples out of a site and look at what kind of DNA is contained in those sediment samples. So they did this at this site. They took a lot of sediment samples. They analyzed them. They found the DNA of a number of different animals, but they found no human DNA in any of the samples. If people were in here using the site for 20,000 years or more, some of their DNA ought to be there in the sediments, but they're not. And I think they're not because people were never present at this cave. It's again an instance of the artifacts are not artifacts. The same thing is perhaps true of the site of Pedra Furada in Brazil, where we've again got some quartzite pebbles that are broken in ways that the archaeologists argue are stone tools. Very crude, very simple stone tools, but they're arguing that they are the only way you could get these rocks is through intentional manufacture by people. That is not entirely true, because we know in Brazil today there are Capuchin monkeys who use the same kind of quartzite pebbles to break open nuts. And there's a photograph of one of them, and you can find video of them on the web of these monkeys breaking open the nuts. They also break open these rocks and then they lick the fresh surfaces, although they're not really quite sure why they're doing that. The other possibility is that some of these stones could be falling from a much higher level. This is a rock shelter site that sits at the base of a very high cliff, and some of these cobbles are occurring naturally up there. They could have been falling out of the cliff and breaking on their way down and then roll into the rock shelter. Again, they've done a considerably large excavation here. This is just a portion of it. The sediments are filled with these broken rocks. Again, if you look at enough of them, you'll find a few that look like stone tools. I reject this site. Then there's the site of Metalcroft rock shelter, another very large excavation, very, very carefully excavated by the archaeologist is Jim Adavaggio standing here, carefully excavated, although we don't have a final report on the site yet. There are some artifacts here that are really pretty clearly artifacts, including a bifacial stone point, some what we call microblade flakes, and a core that there have been microblades removed from the core. The artifacts in this case look much, much better than in many other sites. There's quite a few dates from the site, and these earliest artifacts, there's very few of them, are suggested to be about 16,000 years old. They're found down here in the lower deposit. I have concerns, though, about the association between the dates and the artifacts themselves, because the nature of the deposits that they're found in, as they have been described in publications, leaves open the possibility for the artifacts to have moved downward from an upper level, or the material that's dated to have moved up from it. I can't trust the association between the artifacts and the dates, given the nature of the stratigraphy that this is located in. But it's a little better case, and to me, I can't reject it, but it does have a question mark next to it. Perhaps an even better case is the case of Paisley Cave in Oregon, which again has been very carefully excavated by Dennis Jenkins. This is him standing here. And at this site, they've found some stone artifacts. But perhaps even better is they've found human coprolites, human feces that were left behind in the cave. And these date to about 14,200 years ago. There's some debate about whether these coprolites are actually human or not, but I think they went to considerable efforts to try and demonstrate that they are. They went to considerable efforts to demonstrate that they date to as old as they date. They did multiple dates. They ran the dates at different labs. And I think they've got a pretty good case that somebody 14,200 years ago went up to this cave and relieved themselves in that cave. And if humans, the ancestors of indigenous folks, entered the Western Hemisphere along the western coast, which you'll see in a moment is what I think happened, this should be where we find some of the oldest evidence up here in the northwestern United States. So there's probably still some more work to be done here, but I think this is probably a pretty good case. Yet another one, also up there in the northwestern United States, is the site of Cooper's Ferry, down here, located down here along the river, which has also been very carefully excavated by an archaeologist named Lauren Davis. The artifacts, indisputable artifacts. They've had a little bit of difficulty dating the site, but they've been able to date it. There's also some difficulty with associating the dates with the artifacts, because there are some elements of the way these artifacts were deposited, plus the presence of pits that were dug into the sediments, that make the interpretation of the site a little more difficult, but it appears to be about 16,000 years old. Then down in Texas, there are two sites, although they're actually the same site because they're only, I believe, about 100 meters apart from one another. These are known as the Galt and the Friedkin sites. Again, carefully excavated, indisputable artifacts. We've got some nice blades here, some nice cores, some bifaces, some small projectile points that are, in my opinion, quite mysterious. The dating of this site, of both of these sites, is a little difficult. It's been done using not so much radiocarbon dating, which is the kind of workhorse in North America for dating archaeological sites, because there's not much organic material left in these deposits. That's just the unfortunate reality of some sites. So they've had to use the dating method of OSL, which is optically stimulated luminescence, which I'm still a little, it's good for dating things in a rough sense. It's not, in my opinion, it's still not good enough to date things in a very precise sense. Certainly not as precise as radiocarbon. But these all appear to be about 16,000 years old. And they're not up in the Northwest, but they're down in Texas. Then we've got the site of Paige Ladson. I think I have located slightly wrong there. It's really over here. Which is, this is a really interesting site and a very difficult site to excavate because it's actually underwater in a sinkhole along the Osceola River in northern Florida. This is a tough place to excavate because it's underwater, which is bad enough. But as you excavate down here, the sediments just become completely cloudy and very, very hard to see what it is that you're doing. They've got many, many radiocarbon dates from it. This site's been excavated very, very well. And they've got a handful of artifacts that are found in strata that seem to date to 14,500 years ago. Just a handful of artifacts, and very, very, very few in that 14,500-year-old sediment. It's a kind of deposit where stuff could get moved around and redeposited and redeposited again. But again, the work here has been done very, very carefully, with fully recognizing the potential for redeposition in this kind of wet environment. In case you're wondering why it's underwater, 14,500 years ago, the sea level was considerably lower than it is today because we still had so much water wrapped up in the continental glaciers that were melting, but they were still of considerable size, covering much of Canada. So that these sinkholes would have been just sort of low places on the landscape with a very sluggish river running through the bottom of them. So they could have been places where people were doing things down next to the riverbanks. And the land around here has been very heavily eroded as sea level came up, and a lot of that material got washed down into these sinkholes, such that if you walk around on the land in Florida, you're unlikely to find things that are terribly old because it's all been eroded down into these sinkholes. So if you want to find old stuff in Florida, you're probably going to have to look underwater to find it. Then there's the case of Bluefish Cave up in the Yukon, which has some fauna in it, some animal bones in it, including this horse is an extinct species of horse, which seems to have cut marks on it, sorts of things that humans leave on bone when they're butchering an animal. And this particular specimen is about 24,000 years old. Not terribly odd that it's up here, but the next oldest site in Alaska is about 10,000 years younger. And that's the Swan Point site, about 14,200 years old. There is a team that's going back to Bluefish Cave. It was worked on in the 1970s, I believe. We've never had a full report on the site, and there's a team that is going back there to look at it. We actually have a student who's been doing experimental work to find out what's the probability that these sorts of cut marks could be produced by stone falling from the roof of the cave onto bone. And the answer right at the moment appears to be that it's highly unlikely to produce these kinds of marks just from roof fall coming down from the ceiling. So, okay, Bluefish Cave, there might have been people way up in the northern part of the Western Hemisphere 24,000 years ago, but the gap between these two is a little concerning. Then, probably most recently, we've had this case published in Science of what, well, they really look like human tracks. You really can't deny that. And they've argued that these human tracks are about 22,000 years old. They've gone to some efforts to try and date them with many radiocarbon dates. Obviously, you can't date these tracks themselves. You have to date the organic material that's lying above them and that's lying below them, and then use those ages to give you a bracketing ages of the footprints themselves. The problem here is that almost all of these radiocarbon dates come from a plant that grows in shallow wetland environments called rupia. And rupia is an interesting plant from the point of view of radiocarbon dating because it gets all of its carbon from the water, not from the atmosphere. Most plants get their carbon from the atmosphere through the process of photosynthesis. But rupia gets its carbon from the water. So if the water is really what we call old water, if it's water that's coming up from deep in the ground through artesian wells, which I believe is the case in White Sands National Park, then that water could be really old water. It could be thousands, tens of thousands, hundreds of thousands of years old, which means it's depleted of its radiocarbon, which means when these plants take in the carbon from the water, they're taking in carbon that, although the plant itself may be 10,000 years old, it's the carbon in it may tell you that it's much, much older than that. This is a problem that the researchers are going to have to try and work out. So this is another site with a question mark next to it, in my opinion. Now, we can talk a little bit about in moving from age. We can talk to the question, where did people come from, which is linked to the question of age. And I wanted to bring up this fact, which in my experience, most professional archaeologists reject this idea, but it is out there, and you can find it in the popular literature quite a bit. And the argument here is that an early population came to the Western Hemisphere from Europe, sailing in boats along what would have been an ice front about 18,000 years ago. And they wound up here on the east coast of North America, and then spread to the west and perhaps met a population that was coming from Asia over the Bering Strait, which was dry land at the time, and then eventually down into North America. This argument is based virtually entirely on similarities in the stoneworking techniques of Clovis points and the stoneworking techniques of what are known as Solutrean stone tools that are found here in sort of France and Spain. Um, this argument, like I said, most archaeologists that I know reject it. There have been computer simulations done to try and ask, could people do that? Could they make it all the way across the Atlantic, which is a terribly rough ocean, hunting seals the entire way? And the answer of all these simulations is no. They'd either turn back or they would all perish before they got to the East Coast. The evidence for early folks here, pre-Clovis folks here, is, in my opinion, really, really poor. So it's something worth investigating, but at the moment, if you have read this in some of the popular literature, the professional audience doesn't really buy this explanation. Okay, so let me go back to the question of age. When people talk about pre-Clovis, they're assuming that we know the age of Clovis. And the age of Clovis has been set at something around 12,750 to 13,050 years ago. And I'm going to come back to that in a moment. What you look at here, this gray image here, I won't go into a lot of detail of it. It's called a summed probability distribution. It's one that we produced from the radiocarbon project that Professor Robinson mentioned a moment ago. It's based on 23,000 AMS dates in the continental US. And it shows sort of what you'd expect. Very little probability back here, very few dates. You can think of this as just the number of dates that fall into these different temporal intervals. You have very few here. The population is relatively small and growing at a very slow rate, probably well below 1% a year, growing at a very slow rate, and then eventually reaches a peak. Up here happens to be at around AD 1150. This is a classic exponential growth curve, very slow, but a classic growth curve. It's exactly what you'd expect if the first folks in North America arrived, maybe around 14,000 years ago or so. But do we know the age of Clovis? That age of Clovis, this age range I presented here, is based on 10 sites, only 10. And those 10 sites are the red circles you see here, some down here, and then a few over in the eastern United States. It's also a geographically biased sample. You'll notice there's no dates out here in the western United States, no good dates. And if people arrived across the Bering Strait and came down, especially if they came along the coast, the oldest Clovis is going to be out here. Clovis is here. We can find Clovis points in this part of the world, but they've just really defied our efforts to date them. So what we're left with are 10 sites where we've dated Clovis that are geographically biased. Statistically, this is a really poor sample. You can't simply take it at face value, which is what this date range is based on. Instead, we can approach it in a smarter fashion by looking at doing some statistical resampling, creating hypothetical radiocarbon data sets, which can get quite complicated, but so I'm not going to go into all the detail of it. But my graduate student, Mary Prasiunas, and then my colleague, Todd Suravel, have looked at this problem, and they can argue that the real date range of Clovis is not 12,750 to 13,000, but it's probably something more like 12,750 back to 14,200. And this becomes interesting. If that's the likely Clovis range, you'll notice that sites like Paige Ladson and Paisley Cave are right there at about the beginning of that range. We've got some other sites, Cooper's Ferry, Galt, Friedkin, Metalcroft, that are maybe just a little bit older, and then you get all these other older sites. If humans were here back in, say, 33,000 years ago, then we'd really expect the human population to have started its growth back that long ago. It would have grown slowly and then reached a peak sometime in the late prehistoric period. But it simply means that sites like White Sands, 20,000-year-old sites, 16,000-year-old sites, and Clovis sites should be really, really common. But they're not. They're not common. And if we were to push the start date from 33,000 back to 50 or 130,000, Clovis sites, there should be tens of thousands of Clovis sites out there. But there's not. There's not. So how do we explain some of these early sites? One possibility is that they are failed migrations. People came over across the Bering Strait into the New World, and they failed. People were here, but they simply died out. They went extinct. Another possibility is that it's an explorer population. People came over from the old world, entered the Western Hemisphere, and they were out exploring this land. What's out there? Sort of like Lewis and Clark, that Thomas Jefferson sent west in the early 19th century. The problem is, for sites that are this old, 20, 25, 30,000, 130,000, the likelihood that we would ever find any of these sites is minuscule. Minuscule. It's highly unlikely that we would ever find them at all. Lewis and Clark, we know where they went. They left us a map. We know that they left sites behind, and we can't find the evidence of Lewis and Clark. And those sites are only, a little more than 200 years old. So my explanation for these early sites, Topper, Cerruti, Chiquita Cave, is that they're not what they appear to be. They're not archaeological sites. Otherwise, our archaeological picture downstream should be much different than what it actually is. So what's to explain those other sites, places like Galt, Friedkin, Cooper's Ferry? One possibility is that you've just got artifacts deposited around 13,000 years ago, but they then move. They move up and down. And that's what this simulation here is showing. If you've got artifacts that are deposited at one level, some of them are going to move down deeper, and they're going to appear to be older than they actually are. And we just have a paper that will appear in PLOS One pretty soon here that my colleague Todd Surville did, where he came up with a mathematical way to sort of characterize how intact sediments are. This is a site that's fairly intact. It's the Swan Point site in Alaska. You can see this heavy layer of artifacts here. They form this spike in artifact density at this depth. This is Cooper's Ferry, which instead of forming peaks, it just has a high density here, and then it trails off as you go down deeper and deeper. This is exactly what we expect a site to look like if the assemblage has moved a great deal up and especially down in the site. And anything that moves down is going to appear to be older. Sites like Friedkin, Cooper's Ferry, and Galt all appear to have low stratigraphic integrity. They all appear to be plagued by a lot of movement, including downward movement of archaeological materials compared to many other sites in North America. So I'm not so sure about these 16,000-year-old sites either. We can add to this questions about when could people enter the New World, and I'm just going to look at this very, very quickly to summarize a lot of work. There's two ways that people can come: down through the ice-free corridor between the two ice sheets covering the northern Western Hemisphere, or they could come along the coast. There's a paper that just appeared about a week ago, which argues the ice-free corridor was closed. These two ice sheets had coalesced until about 13,500 years ago. The coast here, along the Alaska Panhandle and British Columbia, is open about 16,000 years ago. That's probably the route that people took, but not before 16,000 years ago. We also have genetic data, which can be used to track when did people enter the New World. And this is based on differences in the genetic information taken from ancient human skeletal remains from various places throughout Asia and then into the Western Hemisphere. And it's based on the fact that you have an initial population that's a breeding population. It splits at some point in time, and those two populations are no longer interacting. By that we mean they're no longer intermarrying and having offspring. Their genetic codes develop these slight mutations, not serious mutations, just the sort of mutations that go on all the time in genetic material. And the geneticists can take the degree of difference between these two populations, the number of mutations, and use that to estimate how much time has passed since these two separate populations were an original population. From this, we can see that the ancestral population of the native people of the Western Hemisphere were present in Eastern Asia into Alaska, an area known as Beringia, about 21,000 years ago. They then split into two populations about 15,700 years ago. One of those would go on to become Southern Native Americans, and the other would become Northern Native Americans. The Southern Native Americans eventually moved down into Mexico. They have a split at 13,900 years ago into Central Native Americans, and others moved to become South American Native populations. In other words, the genetic data, like the geologic data, is telling us that people couldn't have been here before 16,000 years ago. It just doesn't appear to be possible. So I'm going to jump this here to come back to the question: what might we know right now? We know that people were definitely in the Western Hemisphere by at least a little before 13,000 years ago. No archaeologist will dispute that fact, and that fact hasn't changed in basically 100 years of research. Clovis is probably earlier than we can currently document. And I look forward to the day when somebody excavates a site in the northwestern US where we can really solidly date Clovis But for now, we have to rely on some statistical arguments that are quite clear that Clovis is earlier than it appears to be. The genetic data suggests that colonization couldn't be much earlier than 16,000. And the data we have on the passageways that people could move through, the ice-free corridor or the coast, are also not open earlier than 16,000. And it's really not open very early in terms of the ice-free corridor. And this means that any site claiming to be older than 16,000 years old is really hard to accept, because so many other things must be wrong for that argument to be right. So I'm going to say people were not here before 16,000 years ago, and the empirical evidence would suggest it's less than 15,000 years ago. And that might be what we know at the moment, but stay tuned.